Hello, Maurits here. We will today look at, in this video, we'll look at the conical or circular pendulum. And basically it's a pendulum that doesn't move back and forth like this, but instead in a circular motion like this. And if you see that from the side, we can see that the wire here, or the thread, will sweep out a conical shape. That's why it's called a conical pendulum. Let us say that we choose the length of this pendulum to be 12 centimeters. I measure from the center of gravity, not from the length of the wire here, but the center of gravity. And that is 12 centimeters. And I sweep this around, say I choose an angle of approximately 30 degrees. And the question is now, what will the velocity of this be, and how long will the period be? That is what we will solve first, and we will do that in just kind of an ungeneral way. And in the next short video we will look at the formula for this. We will derive the formula for this. Okay, so what do we have here? We have the mass here, the bob, with an angle against the vertical. In this case that was 30 degrees. We have a length of this. In this case that was 0.12 meters or 12 centimeters. And the first thing we do here is draw a free body diagram of this one. And we have the force of gravity, mg, acting on this, and then we have a tension, the force of tension acting on this. And the centripetal force can't be from this one directly, because this is pointing not inwards but directly downwards. So that must come from the tension here. And we'll split the tension in two components, like this. And this part must be equal to that part, but opposite direction, because it doesn't accelerate up or down, so these two must add up to 0. And this part is what we are actually interested in. So that is the force we will look at. And the angle here is theta. So we can make a formula here. We know that the force divided by, so this divided by that is equal to, let's see, which trig function are we dealing with? Tan theta, right? This divided by that is tan of the angle. We can rewrite this by multiplying the mg up as mg tan theta. And this is the centripetal force that will force this to go in an orbit inwards. So we can write the formula we had for the centripetal force. That was mv square over r. And we can simplify something here, right? And so we can multiply the r up here, so that will give us gr tan of theta equals to v square. Square to both sides will give us that the velocity equals square root of gr tan theta. What we have left is to figure out the radius of this. Of course we have that the radius here, now we're dealing with the sine function, right? If we know the length, so we know that the radius equals to the length sine of theta. So that will give us now that the velocity of this will be square root of g L sine theta tan theta. And of course tan theta could be written as sine over cos, but just let's keep this simple for the moment being. So what we can do here is plug in our values. This is the square root of 9.81 times 0.12 times sine of 30 degrees times tan of 30 degrees. So let's pull out our calculator. Sorry. And let's pull out a calculator. And let's try to do this calculation. So 9.81 times 0.12 times sine of 30 times tan of 30, and then shift square root shift ounce will give us a period about 0.6 seconds or 0.58 seconds. Velocity, meters per second. So we have that is our velocity right here, 0.5829. We keep that for further calculations, unless we can use the answer directly on the calculator. Okay, so that will be our velocity. Secondly, we know that our velocity equals to the distance over time, but the distance is simply the circumference of this, so 2 pi r over t. That means that our period is 2 pi r over the velocity equals to 2 pi l sine theta. I had the radius up there, right? Over the velocity that we have. So now I can just take the calculator again and calculate 2 times shift pi times the length 0.12 times sine of 30, that we should know the answer of by heart, but now this is a physics lesson, not a math lesson, so we pretend we don't know it. And of course the problem could be with other numbers, so let's do the calculation anyhow. And then we divide by the velocity that we have already stored there, shift ounce, and that will give us a period about 0.65 seconds. And looking at this, try to make about 12 centimeters again. Seems reasonable. So hopefully we've been able to figure out the answer of this. In the next video we will make a formula for this.